When you picture a glacier, you probably think of a massive, frozen, kind of lifeless block of ice, right? Well, what if I told you that inside these icy giants, there's a whole secret world teeming with life, a world that's now being unlocked as they melt? You know, we hear all the time that melting glaciers mean rising sea levels. And that's true, but it's only part of the story. The meltwater itself, it carries secrets. We're talking ancient substances, biological signals that have been locked away for centuries. So the real question is, what exactly is coming out of the ice, along with all that water?
Okay, let's dive right in. Our story takes us high up into the Himalayas, a region so packed with ice that it's often called the third pole. A fascinating new study has been digging into what's really going on inside these glaciers, and it turns out they have a secret life all their own.
So here is the absolute core idea, the thing you have to wrap your head around. Glaciers are anything but sterile. They are actually home to these complex communities of microscopic life, things like bacteria and algae. You got to think of them as living, breathing ecosystems that are actively capturing, storing, and transforming elements.
And the fuel for this entire ecosystem? It's something called dissolved organic matter, or DOM. The easiest way to think about it is like a nutrient-rich soup. It's made by all those tiny microbes living on the ice, and they create this huge supply of carbon and other goodies that's been building up for a very long time.
And the scale of this, it's just staggering. All the world's glaciers together store about 6 petagrams, that's a 6 with 15 zeros after it, of organic carbon. To put that in perspective for you, it's nearly as much carbon as you'd find in the soils of the entire Amazon rainforest. So what happens when this gigantic carbon freezer starts to thaw?
Well, to find out, scientists had to become detectives. They decided to follow the chemical clues that were being carried in the meltwater, tracking it all the way from these super high-altitude glaciers in the upper Indus Basin down to the river that supports hundreds of millions of people.
So their journey began way up high, right on the glacier, where they took samples directly from the ice. Then they followed that exact water as it trickled into small streams, then merged into larger tributaries, and finally flowed into the massive Indus River. And at every single stage, they were testing its chemical makeup to see how it was changing.
Now, their number one tool for this investigation was this really sophisticated technique for analyzing carbon isotopes. Honestly, you can just think of it like dusting for fingerprints. It lets them trace exactly where the carbon in the water came from and what happened to it along its journey. It's pretty cool stuff.
So how does this fingerprinting work? Well, it's all about weight. See, when the microbes on the glacier chow down on organic matter, they release a lighter type of carbon into the meltwater. But as that water flows downstream, some of that light carbon actually escapes into the air as CO2 gas. This leaves the carbon still in the water seeming heavier by comparison. So by tracking that signature from light to heavy, scientists can prove that CO2 is being released.
And the evidence they found was just undeniable. The carbon fingerprint right at the glacier, it was at its lightest. But as that water moved into streams and then into the main Indus River, that signature got heavier and heavier. This was the smoking gun. It was definitive proof that as the meltwater travels, it's actively releasing its stored carbon into the atmosphere as CO2.
But hey, the investigation didn't just stop with carbon. I mean, if this was a real ecosystem on the move, you'd expect to find other key nutrients too. So the scientists also went looking for nitrogen, which is another crucial building block for life.
And sure enough, they found that the meltwater is also this rich soup of nitrogen compounds. Yeah, most of it is nitrate, but a really big chunk, about 22%, is dissolved organic nitrogen, or DON, which is directly tied to all that biological stuff happening up on the glacier. This confirms it. The water isn't just sterile melt. It's a delivery system for nutrients that can fuel life way downstream. Okay, so we've followed the chemical trail from one glacier system. Now it's time to zoom out and really understand what this means for all of us. How does this tiny microscopic world end up having a global impact?
The verdict from this scientific detective story is crystal clear. Glaciers are not these passive, frozen blocks we imagined. They are active biogeochemical reactors. They grow life, they store its carbon and its nutrients, and as they melt, they release it all, becoming a source of both life-sustaining food for rivers
and, at the same time, atmospheric carbon dioxide. And this isn't just some abstract science for a textbook. As the researchers themselves put it, understanding this whole process is absolutely vital. Managing these changing rivers is critical for the millions upon millions of people who depend on them for drinking water, for farming, for their entire way of life.
To make this even more real, get this. The study estimates that in just this one river basin, this process pumps out over 7 billion grams of CO2 into the atmosphere every single year. That's roughly the weight of the Eiffel Tower in gas released from just one corner of the Himalayas. And remember, that's just a tiny fraction of the world's glacier.
And the situation is only getting more urgent. Projections show that by the end of this century, depending on how much warmer we let the planet get, glaciers could lose somewhere between a quarter and almost half of their total mass. That means this entire hidden cycle of carbon release, it's about to be kicked into overdrive.
So let's just quickly recap the big picture here. 1. Glaciers are alive. 2. As they melt, they release this cocktail of ancient carbon and nutrients. 3. This whole process adds CO2 to the atmosphere. 4. Climate change is hitting the accelerator on all of it. And 5, maybe the most important point, this directly messes with the water resources for over 869 million people who rely on these rivers.
All of this leaves us with one final and pretty crucial question. We've just uncovered one major secret that was hidden in the ice. So as the world's great third pole continues to shrink, what other profound changes and what other hidden secrets are waiting to be unlocked?